Today we're going to be covering lesson 1.4, which is perimeter and area, so something you're familiar with, but they deal a lot within the coordinate plane, which just kind of means that it's on a graph. There's a few other things that they're going to talk about today, which is also classifying polygons, so like different types of names of polygons, and then they get into the perimeter and area. So these were just two warm-up questions that were in the book, and I didn't think they were bad. Notice they want you to find the perimeter and the area. So if you're going to find the perimeter, you just need to add up the distance all the way around. So we know if this is 9, then this side must be 9. But we would need to find this chunk right here. So notice if the whole thing is 30, and we subtract off the 4 and the 3, that would be 30 minus 4 minus 3, so that would be 23. And then once we have our numbers, we can just like start at one spot, and then we just kind of work our way around the figure. So then if this is 13, then this side must be 13. So I'm just kind of going all the way around the figure, and I get 104. And now for area, again, if we were together in class, I'd be asking for some of your suggestions, but hopefully you're thinking that you would draw a line right across here and that you would cut it into two shapes. So if we find the area of the top, we would go 30 times 9, which is 270. And then if we do the area at the bottom, that's 23 by 13, and I don't know that one off the head, top of my head. So 23 times 13 would be 299. And then I would just add these two together. So if I add those together, I get 569 square meters. Okay. Now again, what you're going to see today, if you kind of look ahead after we get through some of the shapes, is they're going to just have you put them on some graphs. So it's not, a little bit more basic shapes, but I still think it's good for you to think about. So number 2 is just kind of a little bit more in depth of a question, but I do think it's still a good thinking question. So it says we have a 2-inch frame, or a frame that's 2 inches wide, surrounds a painting. So if we start with our painting, okay, so my painting is 18 inches by 14 inches. Now you're going to put a frame around it. I know I'm kind of exaggerating how big it is, but notice it's 2 inches in each way. So it's 2 inches all the way around, okay? It says, what is the perimeter and area of the frame? So we just need to make sure we're paying attention to that. So perimeter. If this is 18, the painting's 18, we're going to add 2 over here, and we're going to add 2 over here. So that makes the dimension 22. So whatever the top is, the bottom's going to be the same. Now again, this isn't necessarily drawn to scale, but that's okay. It just gives us a visualization. We've got 14 here, and we're going to add 2 to the top, and we're going to add 2 to the bottom. So that's going to be 14 plus 2, 16, and then 18. Okay? So now we've got our dimensions, so we can, again, just grab our calculator, and we've got 2 22s, and we've got 2 18s for perimeter, because remember, it's like 2 lengths and 2 widths. So our perimeter would be 80 inches. Now, area is going to be the tricky one, and this is the one I really like because it really makes you think. They only want the area of the frame. So if I just simply multiply 22 by 18 together, that's going to give me the area of every single thing, like this whole shape, and that's not what I want. I want just this outer piece. So I like what I've done here. I like that I've taken the area of the whole thing, 22 by 18, but I need to get rid of this. So I need to subtract off this middle part. So I need to subtract off whatever 18 by 14 is. I want to get rid of the painting. So I'm going to subtract an 18 by 14. And that will just give me this border, which is 144. So again, yours are going to be on a graph, but I think that's really good for you to review because it's probably been a while since you've looked at some of those questions. Okay, notice it says essential question. Essential question is really like the heart of the lesson here. So now we're going to get into our polygons and things like that. So I guess the first question is, what is a polygon? So if you look at the 2 boxes here, you can see these are polygons, and so there's different sizes. Notice you've got a triangle and things like that, and then notice over here the classification of not. So if we were in class, I might have you talk to your person at your table, and then I would ask you for some comments. But since I'm sitting here all by myself, what I use with polygons is I kind of think about it in three ways. Is one, it has to be closed. So do you see how like right here, this is a gap? The other thing I kind of think about with this closed is there's no overlap. So do you see how this kind of crisscrosses? In a way, this is a polygon and this is a polygon. But if it's the whole thing, then no. Like right here, do you see how there's like a leftover piece? That fails to be a polygon. So that's like one of the first things that I think about with a polygon. The second thing I think about is it has to be straight. Or if you want to say segments. Now the segments don't necessarily have to be equal in length. Like, do you see how like this one's longer and shorter? It's different angles and things like that. But that's, I know this is an oval, but if you think about a circle is technically not defined as a polygon. Even though it's a shape that we've all learned since we were a kid, it's not a polygon. So this one too, see how it's got a curved piece, so they have to be straight. And then the third one, really, I mean, I don't know if you really have to think of this, but to be a polygon, you have to have 3 or more. I mean, I guess it kind of makes logical sense because if you only had 2 straight pieces, like 1, 2, then it doesn't close. So it can't be a polygon. So you have to basically have at least 3, and that would define your polygon. Okay. So what they're going to have you do now is they're going to have you name polygons and classify them as concave or convex. So just real quick, since it's on this side first, is convex. Convex is basically, I think of it as there's no indent. Like, just notice over here, see how it indents in, and if I were to connect a line across, see how it falls outside? So when you want to think of concave, think about it as like the figure caves in. You can't, this, when you connect it, this would fall outside. On this one, I know it's a triangle, but anytime I go dot to dot, it's either going to fall on the edge or it falls inside. So let's go down 4 through 7 and we'll just at least do this part, concave versus convex. So if you look at number 4, notice if I connect this corner to this one, do you see how it's inside? If I go from here to here, any 2 points that you pick, when you connect them, it's either going to fall on the edge or it's going to fall inside. So then we would call this convex. So just think to yourself, you know, right now, what these would be, okay? Now, I'm going to have to skip this one because do you notice? This is not even a polygon. So we don't say concave or convex if it's not a polygon. Okay, take a look at 6. Think about what your answer would be. And because this right here, that's going to make it concave because the way like it folds in on itself. All right, take a look at number 7. And again, do you see how this is curved? So this technically would be not a polygon. Now, if this was straight, like let's say it was like this, and then it was straight, and then it was straight, and then it was straight, like that. Let's say it was straight, then this would be convex if it looked like that. So that would be convex, okay? All right, then names. If we go over here to the side, we've got all these different names. Now, I'm sure you know 3 is a triangle. Number 4 many times is okay, so 4, many of you might think of 4 as like a square or a rectangle, but right now they want you to think of a generic 4. So when you guys get to chapter 7, they're going to break down all 4-sided figures. So right now, they just want you to think of this as a quadrilateral. So any 4-sided figure is just called a quadrilateral. 5, you might know of, is a pentagon. Obviously, our government building's called a pentagon, so we're kind of used to that one. 6 and 7 can be the 2 that a lot of people get confused because they're so similar. So 6 is called a hexagon, and 7 is called a heptagon. So very similar names. Many of us are familiar with 8, which is an octagon, obviously the animal. 9 is a goofy name. 9 is called a non, N-O-N, and then gon. It's kind of a weird name, nonagon. 10 you might know of is called a decagon. And then after 10, it gets kind of weird. So let me skip 11 for a second and let's go to 12. The prefix, or 12, is really 10 plus 2. So if you think about 2 is do, and then 10 is decagon. So 12 is a dodecagon. Now really beyond 10, besides dodecagon, there isn't really any specific names. So do you see this one where it says n? N is just referring to the number of sides. So n could be 12, or not 12, it could be 13, it could be 11, it could be 20. N just means the number of sides. So if you had like a 20-sided figure, you would just call that 20-gon. So in this box right here, they just put n-gon to represent any sided figure that doesn't have a specific name. So if I circle back to number 11, we would just say 11-gon. Gone, I put, gone. You don't necessarily, I mean, you're not going to see a lot of those ones, so I wouldn't be overly concerned about it, but sometimes people are just curious, like, what's the name of 11 sides, or what's the name of 15 sides? So that's what happens when we get above 10 and 12 and stuff like that. All right, so let's go to number 4. So if we go to number 4, let's count our number of sides. 1, 2, 3, 4, 5, 6, 7, 8. Now I know they're not all equal, but there still is 8 sides. And you'll find out later, I don't know why it comes up in a different chapter, but the word regular, so don't maybe write this on your paper, but if it was regular, that means all the sides are the same length. So obviously this one clearly is not regular. 5, we don't need to worry about then. 6, it is still a polygon, even though it's concave. So if we count 1, 2, 3, 4, 5, this would be a pentagon. And then obviously number 7, we don't have to name. So get used to these names. Make sure you know them because you're definitely going to ask you questions about those. All right, now perimeter and area in the plane. So basically what you just have to do is you have to figure out where this is at. So let's go ahead and graph it. Okay, so we basically have a quadrilateral, and if you are really good with your shapes, you might be able to name that as a parallelogram. But again, those kind of names they get into later. So we need to know the perimeter and the area. So the horizontal ones are pretty nice. We can just count those. Like this right here would be 1, 2, 3, 4, 5. So this would be 5 across and clearly 5 down. So that works really nice. But then this side, or this side, we need to know how long this is. And because it's on a diagonal, we have to use our distance formula. So I'm going to go over here and I'm going to find the distance between L to M. And so that's why they showed you the distance formula earlier in this chapter. So if I do the distance formula, I'm going to do 4 minus 2 squared plus 1 minus negative 2 squared. That's 2 squared. That's 3 squared. So that would be the square root of 13. So I'm just going to leave it in radical form right now, square root of 13, just so that way when I type it in my calculator, I don't get too much error. So for perimeter, I just need to add all these together. So clearly 5 plus 5 is just 10, so I'm just going to type that in as 10. Plus, notice I have 2 of these, so I'm going to do 2 times the square root of 13. That way then I don't get a lot of rounding error. And then notice the perimeter. So as you've probably seen on your quiz, when you have decimals, a lot of times it'll ask you to round to a certain place. So I would probably say 2 or 3 decimal places is fine. Just get in that habit. Now, area is going to be a little tricky here because area is base times height. So technically I can use whichever one you want as the base and the height, but I'll tell you that whenever you deal with height, it has to be perpendicular. So if you use 5, if we use this one as our base, then we have to figure out the height. So the height, you can either go like right here, which I know is kind of weird that it's like outside the figure, but that can be the height. Or you can go in the middle and just go from this side to this side. So you just need something that goes perpendicular. So we can count this. If you notice, it's 1, 2, 3. So then the height is just 3. So if we multiply that together, and I'm just going to write this down so you're kind of following along. Here's the base and here's the height. So the area of this triangle would just be 15. Or sorry, not triangle, parallelogram would be 15. Now again, I could do the same thing if I use this side. No, I'm probably not going to, but I'm just going to kind of show you a rough sketch here. Okay, if this is 13, if I want this to be my base, then I have to try to draw in a perpendicular right here. Which, first of all, if you look at this drawing, that's going to be difficult because notice if I go right here, do you see how that's not perpendicular? So to try to go perpendicular, going left to right is going to be extremely difficult. So I say we just scrap that and go with the easier one, okay? So I believe the next one is kind of a spin-off of that. So there was only really one example like that, but you'll hopefully have a few more to try in your homework. All right, take a look at number 9. Number 9 is giving you the area. So still kind of along the same lines, but a little bit different twist to the question. So let's graph what we know. We have A is -2, 2. We have B. And we know that this is a triangle. So we know that these are going to connect. The question they're asking me is, where is C? Now notice it does say possible, which likely means that there's more than one correct answer for this location. So it also tells me that it has an area of 6. So the first thing I need to remember is the triangle formula for an area, which is 1/2 base times height. So they're giving me the area of 6, and then I need to know these two pieces. Well, I can make this problem hard, but notice again, because it says possible, that means there's more than one right answer. So what if we make this triangle right? Like what if this is a right triangle? So C could be either like somewhere here, it could be here, it could be here, or it could be here, right? I mean, clearly if you want, I can try to put it here. That's just going to make it significantly harder. So my thought is why don't we call this like the base? Because I'm sort of thinking like this, like C, and then here's my triangle. That's kind of my thought. Or I could go this way. I'm just right-handed. So if I do this, I feel like I cover up the picture on you. So that's why I'm using this corner. So let's just say this is the base, which means this is 4 units long. I need to know the height because I don't know how far C should go up. Should C go right here, here, here? Where should C go? Or do you want me to go this way? So let's quick work this out. 6 is equal to 1/2 of 4 times H. If I divide off the 2, I get 3. So that means if I make my height 3, 1, 2, 3, if I put C right there, 1, 2, 3, that gives me an area of 6. So couldn't my possible coordinate be 2, 5? That would be one location. I could go 3 this way, 1, 2, 3. I could go 3 this way, 1, 2, 3. Up this way. I could even go 3 vertical, 1, 2, 3. Let me draw that in with a different color here. 1, 2, 3. I could make the triangle look like this because that still gives me a height of 3. So it still is a height of 3 and it's still a base of 4. So notice again, it says possible. You don't have to give, more than one answer, but you should be able to come up with different answers if asked. Okay? So we got one more question. Again, notice how they're still using all the same concepts like perimeter and area and things like that, only they're just kind of throwing different twists and turns at you. So number 10. Number 10 is asking us to graph 3 lines and it forms a right triangle. And then it says which are perpendicular and find the vertices. So let's go ahead and do this. We reviewed this on the first day of school. So if you remember, this is in slope intercept. So I'm going to start at 1, -1. And I'm going to do my slope up to over 1, up 2. Now sometimes I like to do my slope almost all the way to the corner of the graph because I truly don't know where these other ones are going to come in. So I just like to do it the whole way. And then I didn't bring a ruler with me, so I'm at home. Actually, I probably have one somewhere in this house, but I'll just use the edge of my sticky notes here. Okay, so this is my first line. I'm just going to label that so I don't forget. All right, I'm going to switch colors and do my second line. So I'm going to start up at 4. We're going to do a lot of graphing in this class, and that's why I tried to review some graphing on that first day of class. Now remember that this is a fraction, so this is really -1/2. So I'm going to go down 1 over 2. Oh, look at how nice where they already crossed. So that's really nice. Down 1 over 2. But I'm going to still go to the edge because I don't know where the other line's going to come in. So now let's go up 1 over 2. Again, it's easier just to do it all right now than to have to try to come back and do it later. All right, so there's my other line. We'll call this line 2. And I think I have a blue pen. I'll try to do this one in blue. This line right here sometimes confuses people, y equals x, because there is no intercept, which means it starts at the origin. So you're just going to start right at the origin, and you're going to go the slope, which is 1 over 1. So up 1 over 1. Oh, that's nice. Up 1 over 1. Up 1 over 1. And so we connect these. This is my third line. So the question is asking me is what is the vertices, oh no, it says which lines are perpendicular. Sorry, first one was which lines are perpendicular. Well, I guess I probably could have done that without the graph. Remember, perpendicular means that your slopes are going to be, hopefully you're saying it to yourself, opposite reciprocal. So if I look at the slopes, I have a 2, a -1/2, and essentially a 1. So do you see how the 2 and the -1/2 are opposite and reciprocals? So which lines are perpendicular? I would say lines, let's just say 1 and 2. So line 1 and line 2, they must form a 90-degree angle. So that makes the right triangle. So here's my triangle. So that makes the right triangle that they told me about in the directions. Okay. All right. It says find the vertices of the triangle. Well, these two vertices are the nicest. So you've got 1, 1, and then this other vertice is 2, 3. The problem is the third vertice right here is the nastiest one. And so most of you guys have a graphing calculator. And so I'm going to actually show you how to do this in the graphing calculator. If you don't have a graphing calculator, you could use Desmos, which I've linked in our class. So Desmos is a really nice online graphing calculator for you to use. Or I can show you just how to set it up by hand. So to set it up by hand, you would need the two equations that make up this point. So you would need line 2, so line 2, and you would need line 3. So if you take line 2 and line 3, then you need to solve that to see where they cross. Where's the intersection? If you want to use the graphing calculator, we just go to y equals, and we're going to type that in. So again, you can always pause it if I'm going too fast. I'm just trying to go fast so that the video doesn't become too horribly long. Okay, so I've got them both typed in. I'm going to go ahead and hit graph. And you can see here's my second line essentially, and here's the third. And now we just need to see what this point is. And so we're going to go second, calculate, and we're going to go down to intersect, which this is all stuff that we did in algebra. And you get the little blinking star, and you just want to maybe move it over close by. It doesn't have to be perfect. And then you just have to hit enter 3 times. So 1, 2, 3. And then notice there is my intersection, which, do you see how it's a decimal? We knew it was going to be a decimal because if you look at it, it doesn't cross nicely anyways. So I say we just round, obviously, this off. So I'm going to say 2.6 repeating, comma, 2.6 repeating. And that is our other intersection point. Okay? All right. Please email me with any questions.